Here in the I button and in description box below, you will get complete playlist of Fourier series. Welcome to video number 15 of Fourier series, and in this video we are going to solve second problem on the topic, that is even and odd function. Okay, um, take my words because this question is very important. Okay, one of the most important problem on this topic, that is even and odd functions. Okay, and in the question you can see nowhere it is written like this question belongs to even or odd function, but we can see that the interval is from minus a to a. Okay, that is minus pi to pi. Okay, in the interval it is like minus pi to pi, which is minus a to a. Okay, so we will check whether the given function is even function or odd function or neither nor case. Okay, neither even nor odd function case. So before I move forward, I would request you to subscribe to my channel, and if you learn something from my videos, then please hit the like button and do share the playlist of Fourier series with your friends. Okay, in this way only you can support me. So let us start solving this problem. Very important problem. Okay, take my words. Okay, the question says if f of x equals to mod of cos x. Okay, if the function f of x equals to mod of cos x, then expand f of x as a Fourier series in the given interval, that is minus pi to plus pi. Okay, yes, if you put x equals to minus x, okay, if you put x equals to minus x, in that case f of minus x, that is mod of cos of minus x, we know that cos of minus theta is cos theta, so this is going to be mod of cos theta. Okay, that is mod of cos x, which is equals to f of x. Since on putting x equals to minus x, f of minus x becomes f of x, so we can say that the given function f of x is an even function. Okay, the given function f of x is an even function. Since the function is even function, so we can directly put vn. Okay, that is bn equals to 0. Yes, since f of x is an even function, so we'll directly put bn equal to 0. It means we need to find the value of a0 and an by the help of Euler's formula. Okay, yes. The Fourier series of a given function of an even function is given by f of x equals to a0 upon 2 plus summation n equals to 1 to infinity n into cos of 2n pi x upon b minus a. Okay, yes, this is the formula for even function. Okay, this is the formula for Fourier series of any even function, that is f of x equals to a0 upon 2 plus summation n equals to 1 to infinity an into cos of 2n pi x upon b minus a. And what is the value of b minus a? Here you can see the limit is from minus pi to pi. This is b, this is a. B minus a, that is pi minus of minus pi, that is 2 pi. Okay, here the value of b minus a is 2 pi. So the Fourier series of an even function is given by mod of cos x equals to a0 upon 2 plus summation n equals to 1 to infinity n into cos of nx. Okay, cos nx, and this is my equation number 1. It means we need to find two values only, that is a0 and an. Okay, by the help of Euler's formula. Now we'll find one by one. Okay, yes, here we can see the formula. Okay, the general formula to find a0 by the help of Euler's formula is 2 upon b minus a integration a to b f of x dx. Okay, yes, b minus a is how much? 2 pi. So this is 2 upon 2 pi. Integration a is minus pi, b is pi. Okay, f of x is mod of cos x dx. Now 2 get cancelled. We have 1 upon pi here. Now integration minus pi to pi can be written as 2 into integration 0 to pi. Okay, yes, here we have mod of cos x dx. Now we can see one thing, that is, yes, here 0 to 2 pi, 0 to 2 pi. Okay, it means we are talking about this region. Okay, in this case cos, here we have mod of cos. Okay, cos is here in this region, that is from 0 to pi by 2, everything is positive. Okay, sine, cos, tan, cosec, okay, whatever you take, everything is positive here. But here we have two things positive, that is sine and cosec, both are positive here. But here we have cos. Cos is neither sine nor cosec. So from 0 to pi by 2, cos will become positive. From pi by 2 to pi, this will become negative. Okay, why we are talking about this region? Because the integration is from 0 to pi. Okay, we need to take this whole region. Okay, if you talk about this whole region, this is positive region for cos and this is negative region for cos. Okay, so this is 1 upon pi into 2 into integration 0 to pi. This will become cos and this will become negative cos. Okay, cos is for 0 to pi, okay, when the limit is from 0 to pi, and negative cos when the limit is from minus pi to, okay, so pi by 2 to pi. Okay, yes, pi by 2 to pi. Okay, So I hope this part is very much clear to you, and this is the main conceptual part of this question. Okay, so this is 1 upon 2 1 upon pi into 2. Okay, this can be written as this, that is integration 0 to pi. Okay, this mod of cos will become positive. Here we have positive. Okay, here all the value of cos is positive, but here if you talk about this region, yes, that is from pi by 2 to pi, all the values of cos is negative, that is minus of cos of x dx. Fine, I hope this part is very much clear to you. Now we will simply solve. Okay, which is easy. 2 upon pi. Okay, yes, here we can write, that is integration of cos is what? Sine. So sine integration sin x integration 0 to pi by 2. Okay, here we have negative sign, so we can take this negative here. Integration of cos is sine. Again the limit is from pi by 2 to pi. Okay, now simply put the limits. Okay, yes, so this is 2 upon pi as it is. Here we can put upper limit, that is sin pi by 2, minus lower limit, that is sin 0. With this negative sign, upper limit is positive, lower limit upper limit is negative, lower limit is positive because of this sign. Okay, this is sin pi plus sin pi by 2. Okay, yes, here we can see sin 0 is 0. Okay, and sin pi is also 0. Okay, here we have sin pi by 2, which is 1. Here again we have sin pi by 2, that is 1. Okay, so 1 plus 1 into 2 upon pi, that is 4 upon pi. Okay, so 4 upon pi is the final value of a naught. Okay, so after doing all this thing, finally we have achieved one thing, that is a naught equals to 4 upon pi. After this we will find an. Okay, yes, the formula for an becomes, yes, this is the general formula, that is b upon b minus a integration a to b f of x into cos of 2n pi x upon b minus a dx. Okay, what is b minus a? That is 2 pi. So 2 upon 2 pi, 2 will get cancelled, so we are left with only 1 upon pi. Okay, here we have a equals to minus pi, b equals to pi, and f of x is mod of cos x. This is cos, this will become, if you put b minus equals to 2 pi, this will become cos of nx. Okay, here we have dx. Okay, now this is 1 upon pi. This integration minus pi to pi can be written as 2 into integration 0 to pi. Okay, this is as it is. Okay, this part is as it is. Now, yes, again we will distribute this. Okay, that is from 0 to pi by 2, this will become plus cos x, and from pi by 2 to pi, this will become negative of cos x. Okay, here you can see an equals to 2 upon pi. Yes, integration, when the limit is from 0 to pi by 2, this is cos x. Okay, yes, cos x into cos nx dx, plus when the limit is from pi by 2 to pi, yes, integration when the limit is from pi by 2 to pi, in that case mod of cos x will become minus cos x into, yes, cos nx dx. Okay, I have simply changed the position because first term, first function should be first function should be that function that contains n. Okay, so here we have n, here also we have n. Now we can write this as 2 upon pi is as it is. Now we need to use this formula, that is 2 cos a into sin 2 cos a into cos b. Here we have cos cos, here again we have cos cos, so we are going to use this formula, that is 2 into cos a into cos b. For that we need to put multiply 2 here, okay, and 2 here, and to do that we will divide 1 upon 2. Okay, we will divide 2. Okay, yes, for both the terms. Okay, so 2 upon pi is as it is. Here we will multiply, that is 1 upon 2 into 2. Okay, here again 1 upon 2 into 2. This negative is because of this. Okay, yes, so 1 upon 2 into integration 0 to pi by 2, 2 into cos n x into cos x dx. Take this negative here, that is 1 upon 2 into integration pi by 2 to pi, 2 into cos of nx into cos x dx. Okay, now we will use this formula. Okay, very important formula, and you need to remember this formula. Okay, yes, so this is going to be 2 upon pi as it is, 1 upon 2 as it is. Now here, yes, 2 cos nx into cos x. Here the value of a is nx and the value of b is how much? X. So this is cos a plus b plus cos a minus b. The formula is cos of a plus b into, sorry, plus cos of a minus b. Okay, yes, so here you can see it is cos of n plus 1 into x. Okay, nx plus x. So if you take x common, this will become cos of n plus 1 into x. Okay, plus cos of a minus b, that is cos of n minus 1 into x. Okay, now write here dx. Now solve this part, that is minus half. Here you can write that is cos of n plus 1x plus cos of n minus 1 n minus 1 x dx. Limit is from minus pi by 2 to pi. Okay, now simply integrate. Okay, yes, if you take here, we have total two terms. This is my first term, this is my second term, and in both term we have 1 upon 2, 1 upon 2 common. So if you take 1 upon 2 common, so 2 will get cancelled. So finally we are left with 1 upon pi. Okay, 1 upon pi is final thing that is left. Now if you integrate, okay, now we'll start integrating every term. This will become sine of n plus 1 upon sine of n plus 1 into x upon coefficient of x, that is n plus 1. Okay, here again you can say that is sine of n minus 1 into x upon coefficient of x, that is n minus 1. Limit is from 0 to pi by 2. Okay, now coming to second part, that is minus of. Okay, yes, here it will become sine of n plus 1 into x upon n plus 1. Okay, sine of n plus 1 into x upon coefficient of x, that is n plus 1. Again we have plus sign here, so this will become sine of n minus 1 into x upon coefficient of x, that is n minus 1. Okay, again the limit is from pi by 2 to pi. Okay, I think limit is clear to you. Okay, the limit is from pi by 2 to pi. Now we'll start putting limits. Okay, now we'll start putting limits one by one. Okay, this is the important part of this video, so carefully solve. Okay, 1 upon pi, 1 upon pi. Here if you put upper limit, that is sine of n plus 1 into pi by 2 upon n plus 1. If you put lower limit, this will become sine 0 upon n plus 1. Okay, yes, upper limit positive, lower limit negative. Now coming to second term. Okay, if you put upper limit, that is sine of n minus 1 into pi by 2 upon n minus 1. If you put lower limit, this will become sine 0 upon n minus 1. Okay, yes, we have solved this part here. Now we'll come to this part, and remember one thing, that is here we have negative sign. Okay, yes, so upper limit will be negative and lower limit will be positive. Okay, because of this sign, upper limit is negative and lower limit is positive, because both the term are positive, and here we have a negative. So this is negative. If you put upper limit, that is pi here, that is minus of sine n plus 1 into pi upon n plus 1. Then put lower limit. Okay, so this is upper limit negative, so lower limit is positive. Put x equals to pi by 2, so sine n plus 1 pi by 2 upon n plus 1. Okay, here again solve this part. If you put upper limit, that is pi, with negative sign, this will become minus of n minus 1 sine of n minus 1 pi upon n minus 1. Upper limit negative, so lower limit is positive. Okay, yes, put x equals to pi by 2 here. Okay, this is sine of n minus 1 into pi by 2 upon n minus 1. Okay, now here, yes, this is sine 0, so this will become 0. This is also sine 0, this is also 0. This is sine n plus 1 pi. Okay, if you put n equals to 1, 2, 3, 4. But remember one thing. Here we have n minus 1 in the denominator part. Okay, here we have n minus 1 in the denominator part. So you cannot put n equals to 1. Okay, we are finding an. We are finding an. But if you put n equals to 1, then this term will become infinite. 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 So here an, okay, in the an, the value of n ranges from 2 to infinity. Okay, in an, okay, because of this n minus 1 in the denominator part, we will say that for n ranges from 2 to infinity. It means we need to find a1 separately. Okay, when n equals to 1, we need to find an separately. Okay, so if you put n equals to 1, an will become a1. So after finding an, we will find a1 separately because of this n minus 1 in the denominator part. Okay, I hope this point is clear to you. Now this point will become 0. Okay, now this will also become 0. Okay, yes, now we are left with only 4 terms, that is 1, 2, 3 and 4. Okay, here you can see, yes, sine n plus 1 into pi by 2 upon n plus 1, sine n plus 1 into pi by 2 upon n plus 1. Okay, sine n minus 1 pi by 2 upon n minus 1, sine of n minus 1 pi by 2 upon n minus 1. Okay, yes, this term is repeated, this term is also repeated, so we can take 2 common. Okay, yes, so we can take 2 common, so this is 2 upon pi. Okay, this will become 2 upon pi, sine of n plus 1 into pi by 2 upon n plus 1 plus sine of n minus 1 pi by 2 upon n minus 1. Okay, this thing is clear to you. Now there is something that we need to do. Okay, and this part is important, very 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 important. Okay, let us see. Take this pi by 2 within this bracket, so this will become, this is as it is, that is 2 upon pi. This will become sine of n pi by 2 plus pi by 2. Okay, I am taking this pi by 2 inside of this bracket, so this will become sine of n pi by 2 plus pi by 2 upon this part is as it is. Here again we will do the same thing, that is sine of n pi by 2 minus pi by 2 upon n minus 1. Okay, now we will simply rearrange. Okay, yes, writing this here, writing this here, again here, here. Since both the terms are positive, so there is no change. But here, if you take negative common, this will become negative because sine of minus theta is minus sine theta. Okay, I repeat this once again. Sine of minus theta is minus sine theta. Okay, yes. So 2 upon pi is as it is. We can write this as sine of pi by 2 plus n pi by 2 upon n plus 1. Okay, if you take negative common, this will become minus sine pi by 2 minus n pi by 2 upon n minus 1. Okay, here you can see it is pi by 2 plus. Okay, yes, here we have a full quadrant. Okay, this is 0, pi by 2, pi, 3 pi by 2. Okay, if you want to put 2 pi, here we have 2 pi. Now here we have pi by 2 plus n pi by 2. Pi by 2 means 90 plus. Okay, 90 plus. Let's suppose this is my theta. Okay, so 90 plus theta. It means for 90 we need to change this. Okay, so sine will become cos. Okay, 90 plus. 90 plus means 90 plus. Here we have sine and here we already have sine. So this is going to be positive. Okay, so sine of 90 plus theta will become plus cos theta. Okay, so here we have cos of n pi by 2 upon n plus 1. Now here we have negative sign. Here it is sine of pi by 2 minus theta. Okay, sine of pi by 2 minus theta. Pi by 2 minus theta, it means this area. Okay, and in this area everything is positive. Okay, so negative positive will become negative. Sine of 90 minus theta will become, okay, because of this 90, sine will become cos of pi by 2 n pi by 2 upon n minus 1. Okay, I hope this part is very much clear to you. Now simply solve this part. Okay, so this is cos n pi by 2 upon n plus 1. This is minus of n pi by 2 upon n minus 1. Okay, now we can take LCM because this part is common. Okay, so we can say yes, 2 upon pi, we can take this common, that is cos of n pi by 2. Okay, we are left with 1 upon n plus 1 minus of 1 upon n minus 1. Okay, yes, so 2 into cos n pi by 2 upon pi. Here if you take LCM, this is n square minus 1. Okay, multiply n with n minus 1. Here we have n minus 1 and multiply minus 1 with n plus 1. So it is minus 1 minus n. Okay, minus n minus 1. So you can see n will get cancelled. So we are left with minus 2. So minus 2 into cos n pi upon 2 upon pi will become, yes, this is the final value of an, that is an equals to minus 4 cos n pi by 2. Okay, minus 4 cos n pi by 2 upon pi into n square minus 1. Okay, this is the final value of an. Okay, yes, but remember one thing, here we had n minus 1 in the denominator part, so you cannot put n equals to 1, because if you put n equals to 1, this whole term will become infinite. Okay, so an, for an the value of n starts from 2 to infinity. It means we need to find a1 separately. Okay, now let us find a1. Now we'll find what is a1. Okay, yes, to find a1, simply put n equals to 1. Okay, that is a1 equals to 2 upon b minus a integration a to b mod of cos x. Here we had for an we had cos nx. Okay, for an we had cos nx, but we are finding a1. Okay, we are finding a1, so it is cos 1x, or you can say cos x. Okay, cos x dx. Now b minus a equals to 2 pi. Okay, and value of a is minus pi, b is plus pi. Okay, yes, rest is as it is. So 2 will get cancelled, so we can write this as 1 upon pi. Integration minus pi to plus pi can be written as 2 into integration of 0 to pi. Okay, rest is same, that is mod of cos x into dx. Fine. Now yes, 2 upon pi. Okay, 2 upon pi, here we have. Now this mod of x can be written as cos x. Okay, this mod of x can be written as cos x when the limit is from 0 to pi by 2. Okay, this will become cos x. So cos x into cos x will become cos square x into dx. But from pi by 2 to pi, okay, from pi by 2 to pi, this mod of cos x will become minus of cos x. Okay, so minus of cos x into cos x will become minus of cos square x dx. Okay, yes. Now we need to use this formula, that is cos 2x equals to 2 cos square x minus 1. Okay, cos 2x equals to 2 cos square x minus 1. So cos square x will become 1 plus cos 2x upon 2. Okay, I repeat this once again. Cos square x will become 1 plus cos 2x upon 2. We are going to use this formula here. So 2 upon pi is as it is. Here we have integration 0 to pi by 2. This can be written as cos of 2x plus 1 upon 2. Okay, 1 plus cos 2x can be written as cos 2x plus 1. Okay, cos 2x plus 1 upon 2 dx. Again we need to do the same thing here also, that is minus integration pi by 2 to pi. Here we can write that is cos 2x plus 1 upon 2. Simply write dx. Now we will integrate. Okay, yes, here you can see here we have 1 upon 2 in this term and 1 upon 2 is this term. If you take 1 upon 2 in both the terms, 2 will get cancelled, so we are left with only 1 upon pi. Okay, yes, so 1 upon pi. Integration of cos 2x will become sin 2x upon 2. Okay, integration of cos 2x will become sin 2x upon 2, and integration of 1 will become x. Okay, because we are integrating with respect to x. Limit is from 0 to pi by 2. Okay, now coming to second term, that is this part. Again, if you integrate cos 2x, this will become, if you integrate cos 2x with respect to x, this will become sin 2x upon 2. Now integrating 1 with respect to x, you will get x. Okay, the limit is from pi by 2 to pi. Okay, yes, 1 upon pi is as it is. Now simply put the limits. Here we have sine of 2 into pi by 2, that is sine pi. Okay, if you put pi by 2 in place of this x, 2 will get cancelled, so we are left with sine of pi. Okay, sine of pi upon 2. Okay, now if you put upper limit here, this will become pi by 2. Now simply put lower limit here, this will become sine 0 upon 2 with negative sign, because upper limit minus lower limit. Here also lower limit will become 0. Okay, now coming to, yes, second part. Okay, yes, here we have negative sign here. Okay, so cautiously put limits. If you put upper limit, this will become sine of 2 pi upon 2 with this negative sign. If you put upper limit here, this will become pi with negative sign. Okay, since upper limit is negative negative, so lower limit will be positive positive for both the terms. Okay, now simply put lower limit. So sine of 2 into pi by 2, that is sine of pi upon 2 with positive sign, because upper limit is negative, so lower limit is positive. Again here upper limit is negative, so lower limit will be positive. Okay, simply put pi by 2 in place of x, this will become pi by 2. Okay, now here you can see sine of pi is 0. Okay, sine 0 is also 0, sine 2 pi is also 0, sine of pi is also 0. Okay, so we have only three terms: pi by 2, pi, minus pi, pi by 2. Okay, yes, so pi by 2 plus pi by 2 will become pi, pi minus pi will become 0. So you can say the value of a1 is finally 0. Okay, now after doing all these things, that is after finding a naught, an, when n is not equal to 1, so we have also found that is value of a1 separately, which comes out to be 0. So from equation 1 we can finally say that yes, the function that is mod of cos x equals to 2 upon pi. Okay, here we had the formula that is a naught upon 2. A naught upon 2, it means 4 upon 2 pi, that is 2 upon pi. Okay, here we have negative sign, minus 4 upon pi. Here summation n equals to 2 to infinity. Okay, here cos n pi by 2 upon n square minus 1 into cos of nx. Okay, this part is summation a n into this part is cos nx. Okay, and this is the required, yes, this is the required Fourier series for the function that is mod of cos x. Okay, thank you so much.